From sending rovers to the moon in the 60s to the advanced missions there today, moon landing has always been a big deal. Even in 2023, we've seen several lunar missions go wrong, like Russia's Luna 25 and Japan's iSpace. Even our best technology struggles with this, showing that even though we've made progress, the moon still poses challenges that test our abilities in space. But what could be the reason? What secret lies there on the moon that's stopping us from reaching it? Let's find out the answers in this video. If you remember, back in 1966, the Soviet Union's Luna 9 mission was the first to soft land on the moon's surface, which was a big improvement from earlier attempts. The Soviets had already made history in 1959 by sending the first man-made object to hit the moon. All these failures remind us that landing on the moon is a tough challenge, like taking a big risk. A lesser-known but very important part of this case is the moon's weird gravity. Unlike Earth, which has a fairly even pull of gravity all over, the moon's gravity is uneven and bumpy. Some parts of the moon have stronger gravity than others. This bumpiness is mainly around certain big craters, yet it's related to the extra mass left behind by ancient asteroid impacts in those areas. Uneven gravity refers to variations in the gravitational field of a planet or another celestial body. These variations can be caused by differences in the density and distribution of mass within the body. To give you a sense of how it feels, it's more like roller coasters where rapid speed changes mimic varying gravitational forces and high-altitude locations with slightly weaker gravity compared to sea level. 4 years ago, scientists found something really strange under the moon's south pole. It's a huge mass, estimated to weigh about 2 quadrillion tons. While the idea of an alien spaceship is exciting, it's more likely connected to a gigantic impact that happened about 4 billion years ago. This ancient event left behind a lot of extra stuff, which is why the moon's gravity isn't the same everywhere. This unpredictable gravity isn't just interesting for scientists, it's a real problem for landing on the moon. When spacecraft come in for a landing, they have to deal with this uneven gravity, which can mess with their path, speed, and how they land. When NASA started the Surveyor program in 1966, which aimed to send robotic spacecraft to the moon before the Apollo missions with astronauts, it didn't have a great success rate. Out of 7 Surveyor missions, 2 didn't go well. One of them went off course and crashed, while another lost contact with Earth just before landing, and we never knew what happened to it. But when the Apollo missions with astronauts came along, the story changed. They showed how humans could handle problems in real time, something that robots couldn't do. The Apollo 11 mission is an exceptional example. When Neil Armstrong and his team were coming down to the moon, they had a navigation error that took them off course. The computer on board could only follow its pre-programmed instructions, so it couldn't fix the problem. It was Armstrong's skill as a pilot that saved the day. He took control of the lunar module and guided it to a safe landing with only a few seconds of fuel left. Speaking of this, that's why human intervention is needed, even if we have a lot of efficient AIs. Anyway, unlike missions with human astronauts who can take control in emergencies, robotic missions have to stick to their planned paths and procedures without deviation. Even a tiny mistake can lead to failure because these missions rely on everything going exactly as planned. What makes it even tougher is that the moon is relatively close in space, but it's still far enough away that we can't control things in real time from Earth due to the time it takes for signals to travel back and forth, which is about 2.5 seconds. This delay might not seem like much, but it can be enough to mess up a moon landing. Now, it's interesting to compare NASA's successful Mars landings with the historically challenging task of landing on the moon. The difference is in their atmospheres, or lack thereof. Mars has a thin atmosphere that can help with landing, but the moon has no atmosphere to speak of. Mars' atmosphere allows spacecraft to use parachutes to slow down, which is a big help in managing their speed during descent. While parachutes alone can't achieve a soft landing, they do buy valuable time to control the descent speed, making it more manageable for the final landing phase. After the parachute phase, techniques like airbags or combinations of retro rockets and sky cranes are used to cushion or control the landing. This combination of aerodynamic and propulsive strategies is carefully planned to ensure a safe landing on Mars. In contrast, the moon's lack of an atmosphere means that spacecraft have to rely entirely on propulsion for landing, which is a much more complicated and fuel-intensive process. Going from orbital speed to a complete stop on the moon requires a carefully choreographed series of rocket burns with no help from aerodynamics. This highlights the significant engineering challenge of lunar landings, even for advanced technologies like SpaceX's Falcon 9, which depends on Earth's atmosphere for controlled descents and might find the moon's conditions quite daunting. Modern lunar missions are making things even harder by aiming for more challenging landing spots compared to earlier missions. In the past, missions like Luna 2 simply aimed to hit the moon's surface without much precision, and the Apollo missions mostly targeted areas near the moon's equator on the side we can see from Earth. Traditionally, lunar missions followed a simple path from Earth's equator to the moon's equator and back, keeping things easy and efficient. But things have changed recently, with a lot of interest in the moon's south pole. This area has a ton of scientific potential and the promise of valuable resources. The Chinese space program made a big leap in lunar exploration when they successfully landed on the far side of the moon with the Chang'e 4 mission in 2019. This was a bold move indeed. Now, recent missions like iSpace and Luna 25 are also aiming for the moon's south pole, which is a crucial area for future human lunar exploration. The south pole of the moon is incredibly important for science because it likely has a lot of water ice. Water is essential not just for astronauts to drink, but also for making oxygen to breathe and hydrogen for fuel, which are crucial for long-term lunar missions. But getting to the moon's south pole is way more complicated. It requires spacecraft to follow a more complex three-dimensional path and enter a polar orbit around the moon. However, India's Chandrayaan-2 mission showed in 2019 that it's possible to do this. India's space agency, ISRO, successfully landed at the moon's south pole, proving that with determination, even the most challenging goals can be achieved. The journey wasn't without its problems, as the Vikram lander and Pragyan rover had communication issues after the lunar night. However, these challenges taught important lessons for future missions. India's recent lunar mission this year, Chandrayaan-3, made history by landing on the tough lunar South Pole on August the 24th. This achievement puts India in the company of countries like the United States, the former Soviet Union, and China, which had also successfully landed on the moon. What makes India's achievement stand out is how close it got to the moon's South Pole, an extremely harsh environment with extremely cold temperatures. The Vikram lander, a hefty spacecraft weighing 1,752 kilograms, brought along the Pragyan rover for scientific missions on the moon. During their mission, one interesting challenge they faced was trying to leave marks of the Indian national emblem and ISRO logo on the moon's bumpy surface. This showed how unique and tricky the lunar terrain can be. The Pragyan rover made some groundbreaking discoveries during its explorations. It found sulfur and other minor elements on the moon's surface, which gave us insights into what the moon is made of and its geological history. Also, Vikram lander's instrument for studying lunar seismic activity recorded some unusual movements near the landing site on August the 31st, helping us understand more about the moon's geological processes. However, the mission faced a big problem when the 14-day lunar night came, and temperatures dropped drastically. To survive the cold, the rover and lander went into a deep sleep mode, and their solar panels were adjusted to catch the expected sunrise for energy. But again, the joy of success didn't last long, as on September 22nd, when they tried to wake them up, it didn't work. ISRO thinks that the extreme cold might have been just too much for the equipment, causing the issue. The exact reason for the rover's unresponsiveness is still not clear, and ISRO is working to figure it out. Some people think that Vikram and Pragyan might stay on the moon's surface permanently because of this setback. The situation with the Vikram lander and Pragyan rover serves as a valuable learning opportunity for both ISRO and NASA, especially with the upcoming Artemis 3 mission planned for 2025, which is humanity's return to the moon after more than 50 years. The challenges faced and the analysis of this event will help improve strategies for future lunar missions, making them more successful and safe for astronauts. In space exploration, initial failures often precede eventual successes, as seen in the 1960s moon missions, Ranger and Surveyor, leading to Apollo triumphs. This lesson applies to current lunar efforts, highlighting the need to learn from mistakes despite technological advances. Moon exploration with sufficient funding represents an ongoing quest for knowledge and improvement, echoing the spirit of space exploration across eras. So, what do you think about this? Why couldn't scientists find any solutions to date? How was it only possible for missions like Chandrayaan-3 or Apollo 11? Share your thoughts in the comments below, and don't forget to subscribe for more exciting space updates. Thanks for watching.